Now we want to take a look at the Mastercam Tool Manager interface and the different ways in which we can access, create tool libraries, and make modifications to these tools. First, we're inside of just a blank new Mastercam design file. So we're going to go to our Machine tab, and we're going to select a mill. In this case, I'm going to select my generic Haas 3X mill. And once we do that, we now have a tab that's contextual. It says mill at the top, and we have our mill toolpaths now accessible. Inside of here, we also have a Utilities section, which allows us to access the Tool Manager. When we select this, we have the Tool Manager open inside of the Mastercam application. It tells us which machine group we're currently in, and any tools that are in use inside of that machine group. They'll be listed here. You'll notice that we have a tools millinch.tooldb or tool database file. Parameters that we have inside of a machine group. You'll notice inside of here we have default, and that can be changed in our configuration. We're not going to be focusing on that just now. We want to tool libraries and where they're located and how we can work with them. So first, this automatically takes us into our public documents, our shared Mastercam, our post processors, and into a subfolder called Tools. You want to take the So let's go ahead and So now we have our data set that's provided with this lesson. We file. Also note that on the right-hand side, I have my users public documents and shared Mastercam 2020 file. Tools section. So I'm going to take a copy of this library that's provided with the course, and I'm going to paste. Now if I go back into Mastercam 2020 and into my select open, I should see this library inside. And I can select open. This contains 4 different tools. We have tool number 2, which is drill, tool number 11, which is a 3/8 inch ball end mill, and tool number 23, which is an ISCAR chat here as well. My filters on the right-hand side can be used to filter out. We also have a display mode that can display tools, assemblies, or both. We can see the difference. Have a holder associated with it or an assembly name. If we want to move these up into our Mastercam machine group arrow to push them up into the machine group. Now when we start to create toolpaths, they'll be easily accessible from there. We're seeing here, if we want to take a look at the part tools, which are only in the machine group, the library tools, which are only in the library bottom. We can right click inside of here to create new tools. We can change the tool and editing them. We can edit their holder, their projection, their names, lots of different things that we can do in here, which we will get. Tool Manager, accessing tool libraries, and how to work with this information. This is not also a standalone, which you can find by going into your store, opening up the Tool Manager. There are some differences that we want to talk about here. Selecting a machine, we were still inside of the Mastercam application. The standalone, it's its own program. And each time we open up the standalone Tool Manager, this is going to open up a new version. Open, and we go into 2020 3D Mill ToolDB file, this is going to open up. And if we open up another library, we can open up a second instance of the Mastercam tool manager and open up two versions on your side as well by going into your Mastercam tool time. Open hand side and the left hand side, 2020 mill right hand side, and on the left hand side, go ahead and open up my default mill inch tool library. This was the default that opened up inside of Mastercam. On the left hand side, we see tool assemblies. Is that there are no tool assemblies inside of the mill inch. Tool assemblies, we have one cutting tool and we have no holders that are by themselves in this file. Any of these, what we'll see is a tab that opens up in the bottom as well as an assembly tree. So for example, this a 1/4 inch chamfer mill, which is the name of the assembly holder, we have the actual chamfer mill tool. We can adjust the projection by moving the tool around. And this is something that we will focus on process right now. Just simply note. So again, it's important to note that we have direct manager inside of Mastercam, but we also have the standalone tool functionality. The added functionality is a graph. We can easily manipulate the projection on the screen. We'll have a separate instance of the standalone tool manager for every tool DB that we open up. We have drag and drop functionality, which allows us to take tools, for example, from the default mill inch tool library, and we can simply drag them and drop them over into our tool library that we're working on. So for example, if we wanted to add another cutting tool here, we could go ahead and we could add this 3/4 inch countersink. So now we have tool number 24, which is a 3/4 inch countersink, by dragging and dropping from one tool DB file to another. Now this makes a copy of it. It doesn't move it from one to the other. It simply makes a copy of it in the new location. So we still have it on the left-hand side. It's tool number 275. However, over here, it takes the next available tool number in that tool list, which is 24 in our case. We don't actually need this cutting tool in our library, so I'm going to right-click and select Delete to remove it. So again, let's note that we have drag and drop functionality. We can take tools from one tool DB file to another. Each time we open up a database file, it's going to open up a new instance of the standalone tool manager. And also note that each time we simply close this, it automatically saves because it's constantly connected to the tool DB file. However, changes inside of Mastercam Tool Manager, they're going to prompt us to changes have been made, and we need to simply say yes or no if we want to accept those changes. The last thing that I want to mention, because we are dealing with these standalone options inside of Mastercam, there are also some standalone options for things like Code Expert. Now, Code Expert is something that allows us to see the code that we post from Mastercam. Now, Code Expert might show us what tools are being used in a program, but it's not the right application to create and manage our tools. We want to make sure that we're doing that either in the standalone tool manager that we're looking at here, or back in the tool manager that's inside of Mastercam. We will be going through the process of creating tools and creating assemblies and setting the projection of those in other lessons. But for now, make sure that you're comfortable with where to access this information. So you want to make sure that you can open up the standalone tool manager, and also that you can open up the tool manager inside of Mastercam to get access to that information and work with it in different ways. Once you're done here, make sure that you keep this file open, and we're going to carry on working with tools in the tool manager interface in the next lesson. In this lesson, we're going to talk about how to create a tool assembly inside of the Mastercam standalone tool manager. So I have two instances of the tool manager open. On the right-hand side, I have our MCU 2020 3D Mill Tool DB, and on the left-hand side, I have my Mill Inch Tool DB. So make sure that you have both of these open, And if you have dual monitors or if you have another situation, you can make sure that you can spread these out so you have more room to work. Since we're recording just a single screen, I've got them bunched up a little bit, which will complicate viewing the assemblies just slightly, so make sure that you spread yours out if needed. The first thing that I want to do is I want to double click on Tool Assemblies on the right hand side in my MCU 3D Mill. Then I also want to double click on Cutting Tools and Holders. So notice when I do this, it adds tabs to the top, and again it changes how we can see the information on the screen. However, inside of the standalone tool manager, we can do a few things that'll help. For example, since I'm dealing with kind of a tight area here, since I've got two instances open, I can close the properties. I can also grab this and move it around and use some of my tiling options to show my assemblies as well as my tools and holders in different orientations. So now I have the assemblies down here and I have the holders and tools up here. On the left hand side, I'm going to double click on holders because that's really what I'm interested in focusing on. When I look at the assemblies that I have inside of my MCU 2020 3D library, I have three assemblies. I have a chamfer mill, I have a 5/8 drill, this 3/8 ball end mill. The last tool that I have that still needs is going to be my ISCAR chatter-free full nose mill. Flat end mill with a corner. So this allows me to use it for roughing as well as finishing applications anywhere it's a rounded, filleted corner on our final geometry. So what we want to do is we want to create an assembly for this tool. The holder that we have inside our assembly here for our spherical is a B4Y4-0562. So we want to look for that same holder because we don't have it loaded inside of this library. We only have our tool assemblies and our cutting tools. So if we want to build it, we actually need to put that holder inside of this file. You can see in our assembly tree down here, we have the B4Y4-0562. So that's what we want to start to filter and look for. So over here on the left-hand side in our Mill 2020, what we want to do is we want to search for a specific holder. So we have some different conditions here. You'll notice that it automatically is searching for holders because that's what we were working with. So the search item that I want to look for is going to be the name. So I'm going to select name and it equals this value. So I'm going to start to type in B4Y4-0562 and then I'm going to hit enter and search. And what this will do is it'll search for this specific holder, and of course it only finds one because it's a very unique name. So notice that this search dialog box popped up outside of my standalone tool manager. But what I want to do is I want to take this holder and I'm going to drag and drop it over into my holders on my MCU 2020 3D Mill Tool DB file. Then I can go ahead and I can close the search option that I have that was searching my tool database. And now I'm going to minimize my inch and I'm going to maximize the MCU 2020 3D Mill Tool DB. So now what I have is the assembly on the bottom, and then I have my tools and my holders up here. So I'm going to take this tools and I'm going to tile it on the right hand side. So now I can see my tool and holder, and then I can see my assemblies at the bottom. So I want to create a new assembly. So in the assemblies, I'm going to come down here and I'm going to right click and notice that I don't really have any new options here to create a new assembly. If I want to make a new assembly, I need to come up to new component and select the assembly option. So I need to give it a name, and I'm going to give this one a name, and it's going to be my ISCAR chatter-free mill. Now we can take this specific from the tool name that we want, or we can make any additional adjustments. We want to make sure that it represents the tool and the holder that we have. And to build this, we can use the drag and drop functionality. So currently, tool number 12 is highlighted on the screen. I'm going to drag and drop the holder, and I'm going to bring it down into this assembly tree. As soon as I do that, the assembly name automatically takes on B4Y4 because that's the only thing in there. Then I'm going to come up to my tools, and I'm going to drag and drop this onto my holder. So now that I have the tool in there, notice that the name changes to chatter-free underscore ECI, and this is the part name that we have here. Now notice that we don't really have any properties here that we can change, and we did close the properties view on the right hand side. But if we go to our view tab, notice that we have some options over here and we can bring the properties back. So if we change the view a little bit and we bring the properties out a little bit more, you can see that the description right now is empty, but the assembly name is this chatter free option. So what I want to do is I want to get rid of some of this other stuff in here, and I'm going to call this a 1/2 inch bull nose, and I'm going to call this an ISCAR. So I know which tool that I'm working with. So now that I've changed the name of that, you can see that it's populated my assembly section. And again, we can modify any parameters that we want. Originally, this tool might have been a different number instead of 12. It might be a different position inside of our tool changer. So maybe this is tool number 6. And again, we can make adjustments to that directly in these properties. So let's go ahead and bring this back over. We don't need to see as many of those properties, but now we have our assembly, and all 4 of our tools currently have assemblies. We have our 3/8 ball and our 1/2 inch bull nose mill, and they're both using the same holder. And then we have our 5/8 drill and our 1/4 inch chamfer mill. Now that we can actually see all of our assemblies, I'm going to close the holders. I'm going to close the tools, and I actually don't even need to see the start page. If I want to bring it back, I can use my view options to show the start page, but really all we need to focus on right now is the assemblies. So I have my assembly. Inside of here, you'll notice when I hover the cursor over, it highlights the holder. You'll notice that there's a small arrow next to that, and if I hold down the control key, you can see that that changes. What we're doing right now is we're changing the tool projection. We can also see this information in the properties dialog box. Currently the tool is extended out 3.5 inches. If we hold down the control key and we hold down the left mouse button, we can drag and drop this, and you can see there's a spot on the screen. If the cursor or the mouse is down below the ruler, then we can sort of free drag. If we put it on top of the ruler, it's going to snap to the different increments, in this case every 1/8 of an inch. So if we want to make the projection, let's say 2.5 inches, we can snap to that location. We can also manually change that value. Let's say that it needs to be 2.75, and we can modify it in the parameters. So now that the properties, the tool projection parameter has been changed and all the assemblies are created, we don't have to do anything else in here because, again, it's directly connected to the database. It automatically saves. So I'm not going to close this, but I'm going to minimize it. And I'm going to go back into my tool manager inside of my file here. All right, so as we're looking at this, I'm going to go in and I'm going to take a look at my MCU 2020 3D mill, and I'm going to display only my assemblies. And have the quarter, the 5/8 drill, the 1/2 inch bull nose, and tool number 11, which is the 3/8 ball. They all have an assembly name, they all have a tool name. And if I show both, you'll notice that that's the tool. That's what is in our database. We have the tool that is sort of without an assembly. We have all the assemblies that we can use as well. And this is going to be an important consideration because we want to make sure that the is being represented and not just the tool itself. Information is important because we need to make sure that the holder is accounted for, the amount that the tool or the projection of the tool is sticking out can really be used so that way we understand if we're going to have any collisions with the holder, and we can check for that. Since we don't need just the tool itself, I'm going to right click and I want to get rid of this. Now notice that we have delete tools and delete unused tools. Because we haven't made a program yet, we don't want to use delete unused tools. We just want to simply get rid of that one. All right, there's also a way that we can check projection in here. If we select a tool and right click, we can edit the projection. And what that does is it actually allows us to snap to geometry on a model. And in this case, we don't actually have any geometry. So I'm going to hit O on the keyboard, and O on the keyboard will snap to the origin. And then we can move the holder up and down. And again, if we do this over the ruler in this case, we can manually snap to those locations. And then once we click and we're happy, we can enter on the keyboard, brings us back into the tool manager. So I'm going to say, okay, I made those adjustments in that case. inside of my machine group. I didn't make it in the tool library, so it only affects our machine group. But there's a lot of functionality that's built into both the tool manager inside of Mastercam as well as the standalone. But some takeaways from this are that it's important that we build these tool assemblies and we set the projection of the tool so we understand how far the tool can reach, if we have any clearance issues with the holder, any of that other information that is beneficial to checking clearances when we have those tools and those holders assembly built. Note that we have the tool lists and we have our manager that we can look at all the tools and the assemblies, but it doesn't have any specific information about any tool paths. That's all going to come from the toolpath group and the information that we program. Also note that the standalone has the drag and drop functionality. We can bring a holder from one tool library to another. We can drag and drop the holder and the tool inside of there to build our assembly. And then we can modify those parameters such as the projection, the tool number, the name. We can modify all those directly inside of our tool manager. So from here we have our tool manager set up pretty well. There's some parameters that we need to adjust from here, but at this point make sure that you have closed the tool manager inside of Mastercam and saved any changes that you've made to it. And from here we'll move on to the next lesson and we'll continue on creating some new tools. Now that we're familiar with the Mastercam tool manager, both the standalone and the one built into Mastercam 2020, we know how to create tool assemblies and use the drag and drop functionality. We now want to talk a little bit about creating a new tool. So this can be done in the standalone tool manager or directly inside of Mastercam. We're still in the same file that has a machine group created so that we can get access to our tool manager, and we're working inside of the machine group. So we're going to be creating a tool inside of here, and ultimately we're not going to be using it, but we want to play with the functionality. So there are some differences that we want to note between the standalone tool manager and the one that's built into Mastercam 2020. The standalone tool manager will not allow you to import step files to create a custom tool. So that's still something that needs to be done in the tool manager built into Mastercam, and this is where we're going to focus our attention. And while we're not creating a tool based off a step file, we do want to note that there is a difference there. So in the top section of our tool manager inside of the machine group, I'm going to right click and select Create Tool. I do want to note that if we're inside of the standalone tool manager, so if we take a look at the one that we were working in, we can create a new assembly like we did, or a new holder. And if we want to create a new milling tool, we have the options to create any of these new types of tools, as well as the question mark option for a custom tool. And then we have some accelerated finishing options and hole making options as well. So there's a lot of graphical interface that happens there, but ultimately what we're doing is we're creating the same thing. So inside of the tool manager, we can decide what type of tool we want to create. And there's a custom tool option. And of course we have the accelerated and hole making options as well. If we select the custom tool option and select next, it'll automatically begin to populate the tool based on some common parameters. So you'll see here that it has a 1/2 inch cutting diameter, an overall length of 4 inches, and a cutting length of 1. We have a preview on the screen, and then we have some options above this. We can import and link custom geometry from a level in Mastercam. Now at this point in our course, we haven't really talked about levels or the creation of geometry, so we're not going to explore that option. But just note that we could create a tool based on geometry, wireframe geometry in this case, that we created inside of Mastercam. We also have the option to save the profile to a level and link that geometry. Then we have the option to import custom geometry from a file. Now this is how we would bring in step information, but if we select this, you'll also note that we also have some Mastercam files in here that have information. So if we, for example, take a look at Taper Mill, if we select Taper Mill and select Open, it brings in the source file location, which is tapermill.mcam. It gives us all the information on the screen, and you'll notice that we get a few different options in here. This one allows us to break the link, we can reset the profile geometry, and we can also change what we're looking at. We can render the Mastercam tool, which is based on the parameters, or we can render the imported tool. So I'm going to cancel this because again, I'm just going to create a basic tool just to show the process, but just note that we do have some other custom options. The tool that we're going to create is a flat end mill. We're going to select next. Then we want to define the geometry for this specific tool. So first off, we're going to leave the 1/2 inch cutting diameter, the 4 inches overall length, and the 1 inch cutting length. The cutting length is going to drive this yellow or gold section on the tool. So from here, we can also decide whether or not it's going to be edge break or if it's going to be a bullnose mill or a ball end mill. We can change these parameters in here. And then we can define the non-cutting geometry. For example, changing the shoulder length, changing the diameter of the shoulder as well as the shank diameter, and we can modify the way that the geometry is created. Now, of course, when we're creating a custom tool, we really should be replicating a real tool. We don't want to just come in and start putting in numbers that don't make any sense. We need to match a physical tool. From here, we go to next, and in here we create information about the tool number, and in this case, the tool number, the length offset, and the diameter offset are all going to have the same number, so that way the information in the physical machine on the shop floor matches the information about these parameters. We can change the feeds and speeds if we want to increase the spindle speed. For example, let's say this tool can actually go 5,000 RPM. We can change the surface feet per minute or the feet per tooth, the number of flutes, the feed rate, the plunge rate, and the retract rate. And then we have this calculator option to calculate those based on some other parameters. The information about the material, spindle direction, as well as some information about the coolant. Now, if it pops up on another screen, make sure you pull it over. We can determine whether or not we want to turn on or off flood coolant. Information about offsets that change. For example, if we want to change whether or not this can be a writing tool or a finishing tool or both of those, and whether we want to modify the feeds and speeds based on certain parameters. Once we're done, we can select Finish, and it's going to create that new tool for us directly inside of our tool library. So again, the intention is not for us to actually use this tool, but simply to go through the process of creating that tool to make sure that we understand our options whenever we're working with custom tools that we need to make on the fly.